Hello again. So today we're gonna look at solving right angle triangles. We did lots of practice with just plain triangles and a little bit of word problems, but today we're gonna really focus on the word problems and using our right angle triangles and our SOHCAHTOA. So two things I just want to make mention is some of the questions will say angles of elevation and some of them will say angles of depression. So I just want to show you what that actually means. So angle of elevation usually means that you're looking up at something. So it usually refers to this angle here at the bottom where you're the person and you're looking up to a tree or the top of a building. So it's this angle here. This is your angle of elevation. Now, angle of depression usually refers to when you're looking down at something. So it might be that you're at the top of a cliff, or you're in an airplane looking at the runway, or anything like that. So it just means that you're looking down. Now, it always goes with the horizontal, so that angle is here. This is our angle of depression. Now, when we did our angle properties, we'll remember that if your lines are parallel, this angle is the same as this angle. So it kind of helps you set up the diagrams properly when you're given examples that talk about angles of elevation and angles of depression. Okay, so now let's look at an example, and I'm going to show you what happens. We're going to do the whole process with this example. I'm going to show you steps that I would take when I have a word problem. So first of all, a small plane is flying at an altitude of 3,500 meters over Lake Ontario toward an island. The angle of depression is 15 degrees. How much further does the plane need to travel before it is directly over the island? Okay, so first of all, we've got this plane. And it is traveling towards an island. So I'm going to put the island here. Now we know that it is flying at an altitude of 3,500 meters and that its angle of depression, which if you remember from above, the angle of depression was right here and it was 15 degrees. But if we also do this, this is 15 degrees. So here we have, this side is 3,500. Our angle is 15 degrees, and we need to find out how much further does the plane need to travel before it is directly over the island. So we're going to be looking for this. Perfect. Now, once we've got the triangle, the next thing to do, so I'm gonna put steps. Step 1 is the diagram. Step 2, we're gonna pick our ratio. Now remember that we have sine, cos, and tan to choose from, and we're gonna base that on what we know and what we're looking for. So this is our angle of reference, our 15. So across is our opposite. This is our adjacent. And this one is our hypotenuse. Okay, so you're going to, so that involves labeling the sides, which I just did. And we're going to pick our ratio based on what we have. And we have our opposite, which is 3,500. And what we need or what we want. And we need to find our adjacent. So go back to SOHCAHTOA and I think which ratio has our opposite and which one has our adjacent. And if you remember, or if you have it in front of you, it's okay to always have it in front of you, is that tan was opposite over adjacent. So that is the one I'm going to use. I'm going to use tan. So once you figure that out, that's probably the hardest part, is you're going to then use the values and we're going to solve for it. So tan A is 15 degrees. That's our angle. Our opposite we know is 3,500 meters. And the adjacent is what we're looking for. Now remember when it was on the bottom, all we did was swap. So I'm going to do that. And I'm going to become, it's going to become whatever it is, 3,500 divided by tan of 15. So 3,500, if I do tan of 15 on my calculator, I get 0.26795, and then we'll just divide 0.26. And I get that he has to still travel 13,062 meters. Now, if you want to change that into kilometers, just divide by 1,000. And so he's still 13 kilometers away. All right, moving on to the second example. The Royal Gorge Bridge Incline Railway in Colorado is the steepest railway in the world. The elevation increases 1,096 feet over the 1,550-foot incline. Calculate the angle of inclination or angle of elevation of the track. So in this case, we're looking for an angle. So let's draw it. So we know the elevation increases by 1,096 feet. And the incline is 1,550. So the incline is that diagonal part. So that's step number 1. We're going to draw the diagram. Step number 2 from the previous was to label the sides. Now, because we're finding the angle of elevation, that's this angle here. So we need to label accordingly. So here's our opposite, our hypotenuse, and our adjacent. So notice that we have our opposite and we have our hypotenuse. So if I remember back to SOHCAHTOA, sine, cosine, tan, the one that had opposite and hypotenuse was sine. SOHCAHTOA, so sine. So I'm going to use the sine ratio and we're just going to go right for it. So sine of A, I'm going to label this angle A, is our opposite, which is 1096, over our hypotenuse, which is 1550. We're going to divide 1096 divided by 1550, which comes out to 0.707097 if I round it. And then we're going to second function that, so sine to the negative 1, which is that usually second sine, because it's right over top of that on your calculator. And when we do that, I get that it's 44.999. 44.999. I'm just going to round that to 45 degrees. So then I could say that the angle of inclination, or the angle of elevation of the track, is a 45-degree angle. That's pretty steep for that, for a railway. But you get it, how it works. Cool. Let's move on to the very last. All right, so here's our last example. You are standing between two buildings. So I'm going to draw two buildings. This will be building 1 and this will be building 2, and you're standing in the middle of them. There you are. You're 10 meters from the first building, and it has an angle of elevation to the top of 75. So this is 75 degrees, and you're 10 meters away. And the second building, you're 20 meters away. 20 meters, and has an angle of elevation of 43 degrees. How much taller is the taller building? So the first thing we're going to do, we're going to find out, we need to know the length of 1 and the length of 2, and then we're going to compare them. So we kind of have to tackle this 2 triangles at a time. So the first one I'm going to do is the one labeled number 1. So if this is our angle here, we're going to label it accordingly. So our opposite, our adjacent, and our hypotenuse. And then I'm going to think I have the adjacent, and I'm looking for the opposite. So adjacent, opposite, I'm going to use tan. So tan 43 equals our opposite over our adjacent, which is 20. And because it's on the bottom, we're just going to move it and multiply. So 20 times tan 43. So if I put that in my calculator, I get 18.6. Let's do the second one. We're going to kind of do the same thing. In this case, this is the opposite, adjacent, hypotenuse. So same thing, we have the adjacent. We're looking for the opposite, which is the same. So we're just going to use tan again. So let's quickly do this one. Tan 75 equals opposite over the adjacent, which is 10. Again, we're going to move it. So 10 times tan 75 equals opposite. And when I calculate that, 10 times tan 75, I get 37.3 equals our op. And the last thing, the question says how much taller is the taller building? So we're just going to find the difference. 37.3 minus our 18.6. And the difference is 18.7. Taller. And that is how it's done. There's some examples for you guys to try and a quiz. Have fun.